Now, we learned how to add a vector to another vector. And then you know how to subtract one vector to another vector. The same idea. You just subtract one by one, the first minus the first, second minus the second, the last minus the last. And we also learned the dot product of two vectors. Now, let's move on to the next concept. We call it matrix. Well, we can put multiple column vectors side by side or multiple row vectors row by row, and then to make a table of numbers. Such a table of number, we call it matrix. The plural word is matrices. Give you an example. Well, if you come to my office, ask me, hey, what is my standard right now? And then I'm going to pull out a Microsoft Excel file, record all your test scores, homework scores, and the project scores or final, everything. That's a number table. And you see the rows. Each row have the record of each individual student. And like John, Mary, and Joe in the rows. And each column, I recorded the test, like the test 1, test 2, homework, quiz, final, project. So you can see the table. And then, of course, in the end, I might get the weighted average. That's where you stand. So in such a table, each element is meaningful. For example, this element will show the score of John at the second test. Well, and this element will show the score of Mary in the first test. So if you want the two matrices, the two tables be exactly the same, and then all the cells must contain exactly the same number. So that's how we define the two matrices equal each other. You get to make every element at the same position exactly the same. Now, give you an example. 1, 2, 3, 4, 5, 6 equals only 1, 2, 5, 6, 4, 3, 4, 6. If you change one element, let's say here equal 2, they're not equal. Or you can let this one turn around. You have the same number, but they're still not equal the previous one. This is not equal. Actually, later on you learned this second one, the blue one, B is equals the red one, let me call it A, called it the transpose. Transpose, you will put a prime, means you change the row into column and the column into row. Some book use that letter, put a T. It's called a transpose, the variable, vector. So what I introduced there as a number table, they're really in mathematics, we call them matrix. And it is a rectangular array or a two-dimensional array of numbers. And if you have m row and n column, we call this as a n by n matrix. In this case, the A is a 2 by 3 matrix, and the B is a 3 by 2 matrix. Now, let's use a matrix to represent the population of the two types of sharks in the first example. Let's look one more time. In this example, we have WTS and the BTS observed 6 months of their weight, and now with the new language, all we need is write into a matrix. And the 6 months stand by 6 rows and 2 types by 2 columns. And then the table 1 in mathematics is a 6 by 2 matrix. And in computer science, you call it a 2-dimensional array. Either way, it's the same concept. So when we look at the matrix, I used quite a few of those subscript here. Put the ij. This ij, the first letter I represent the column of the matrix. Second, j represent the first one is the row. I'm sorry. Second one is the column. So in that case, what is this element? This 2, I will call it as B2, 2, because it's the second row, or 2, 1, I'm sorry, first column. And then this one is B2, 2. And let's take this one. That one, 6, is the A2, 3. Now keep that. We don't need the cross, just the 2 to 3. Sometimes you put a common, but most of the time we just say A2, 3. You don't read it as 23. Okay, that's the subscript. So in the shark matrix, look at this 6. What does that mean? That is the element S, the row 4, and the second column equals 6, map to the original table. You know, this is the BTS, the weight of black tail shark in the 4th month. It's meaningful.